Okay, in this section, or this part here, we're going to look at the logarithmic function y equals log base 2 of x. Okay, now we can start with the function y equals 2 to the x. We can sketch the graph of that function, and to do that, if we want, we can plot points. Okay, so roughly that's how it looks. Now, the function y equals 2 to the x power is increasing. We can look at that and see that's true. Therefore, it is 1, 2, 1. We can also note that it passes the horizontal line test. That's another way I can see that it's 1 to 1. Okay, so what's all that 1 to 1 about? All right, why would I say this is a function? The reason this is a function is because each x value has exactly one y value. If I draw a vertical line through, say, x equals 1, then I get exactly one y value. So each x corresponds to one y value. If I go and draw a horizontal line through 2, I see that I get exactly 1 point. That means that for this value of y equals 2, there is exactly one x value. So for each y, there is one x. So when we have our picture here, if you wanted to write it this way, we have the domain and we have the range. We see that for our x value here, x equals 1, and this is for the function y equals 2 to the x. Actually, I should leave off x and y. I don't want to do that. But anyway, y equals 2 to the x. For y equals 2 to the x, 1 goes to 2. But if I wanted, so that's why this is a function, because 1 goes to only goes to 2. It doesn't go to any other values. So I start off with x equals 1 and it goes to 2. If I wanted to go backwards, I could do that, and 2 would go to exactly one value of 1. That is the inverse. Inverse is taking the y value and going back to the x value. The inverse function of y equals 2 to the x is y equals, all right, now, well, I'll tell you what it is. It's log base 2 of x. Now, the thing is that the way we find the inverse in general, if we have a function, is we solve for the x. Let's just look at this. Let's just go over here and say, find the inverse function. So if I have y equals 2 to the x, I first switch x and y. So I get x equals 2 to the y, and then I solve for y. Well, how am I going to do that? I can't divide or multiply. What I'm going to do is we define, just by definition, y equals log base 2 of x. We cannot get to this y equals some function of x without defining this logarithm. We can't divide or multiply or add or subtract. Okay, so this is the inverse function. Now also, let me go back over here. I talked about the function y equals 2 to the x is 1 to 1. and it passes the horizontal line test. What I did not include here is, why did I care about being 1 to 1? Is that therefore, because it's a 1 to 1, y equals 2 to the x has an inverse function. So the reasoning is that you start off with, is the function y equals 2 to the x 1 to 1? Yes, because it's increasing. Increasing functions will always pass the horizontal line test. So therefore, because it's 1 to 1, it has an inverse. Now, if we go ahead and try to find the inverse, which we've done in other sections, the step-by-step process is you switch x and y, and then you solve for y. But when you get to this point where it says x equals 2 to the y, you cannot find y by adding or subtracting or dividing or multiplying. Instead, we have to define a new function, which is y equals log base 2 of x. So log base 2 of x, y equals log base 2 of x, means it's the exact same meaning as x equals 2 to the y. Those are the same thing. And that's how we can define logarithm. Logarithm is the inverse. Log base 2 of x is the inverse function of y equals 2 to the x. And for y equals log base 2 of x, this guy here is called the base. So I like doing base 2 because I can sketch the graph easily. It's not really what in math we don't usually use base 2. However, now with computer science, I think the base 2 could be often used with computer science because they have used 2 often. But we're going to use a different number for our base for the most part.